So this is a short follow-on from my previous demonstration on how to calculate the shot resolution from the focal length. In this demonstration I'm going to complete the round trip by calculating the focal length from an image resolution instead. The situation might occur, for example, when the matte painter isn't quite sure how much resolution they're going to need in order to complete the artwork. Or it could also happen in a situation where the creative direction is still sort of in some flux and subject to some change, and the matte painter wants to basically hedge their bets by making sure they've got plenty of real estate. Okay, so you can see that I've got the image that we worked on in the previous demonstration open in Photoshop. Just to demonstrate that, I'm going to go to image size just to bring that up, and you can see that this is 1280 by 720 pixels. Okay, so like before, I want to change the canvas size to raise the resolution. So I come to image, canvas size, switch over to pixels if it isn't already, and this time I'm going to create quite a large overscan, quite a bit larger than the last time, so let's go for something like this. So 2500 by 1406, so pretty much double the size of the original matte painting, or the original plate should I say. Okay, so this is what we see. We can see that we've got a huge amount of overscan available to us now. So I'm going to save this file out, so I'm going to come to Save As, and I'm going to call it MP Projection 50. I'm also going to append it with the 2500 by 1406. So we know that it's a projection, we know that it's from frame 50, and we know that it's got a resolution of 2500 by 1406, so pretty much belt and braces. There's no ambiguity whatsoever about what this image is for and where it fits into the project. So I'll save that now. There we go, and I can shut Photoshop down now and switch back to Nuke. So this is the script that we left off with at the end of the previous demonstration. Okay, so we can see all the node graph that I used to construct that, and we can see the workings out still listed inside this backdrop. Okay, so what I want to do now is I just want to bring in my image that I've just created in Photoshop, and I'm just going to hook the viewer to this, just so we can see that this image, we can see all of the overscan area around this outside, and we can see the resolution here is 2500 by 1406. So we know that there's no ambiguity there. That's our new image. Okay. So before we go any further, what I'm going to do is I'm going to copy all of this lot, and then come over here into space and paste it. There's absolutely no point recreating all that. We need pretty much the same script. Okay. What we don't need is the checkerboard and that old matte painting, because we're working on a different project this time. Also, we don't need the right node. What we do need to do is make some changes in here. So let's make a start by double clicking it to open it up in the viewer here. So what do we know? We know the original focal length was 62. We don't know the new focal length. That's what we're trying to achieve. And the calculation that we used to establish that originally, which was dividing the original by the new focal length, that's no longer relevant for this particular thing. Okay. Tabbing down, we know the original resolution was 1280 by 720, and the new resolution is now 2500 by 1406. Okay, so we've got a couple of holes that we need to fill. Our first calculation is to divide the original resolution by the new resolution to work out the difference between the two. So if I bring up my calculator again, so our original resolution was 1280, and we need to divide that by the new resolution, which is 2500, and that gives us this value of 0.512. So we're going to add this in down here. So original res is divided by new res equals 0.512, and that's the number that's going to give us our new focal length. So if we come to this and we multiply this value by the original focal length, which was 62, we get this value of 31.744, and that is our new focal length. So if we come back to the top there and paste that in, and we should be good to go. So let's test it out. So I'm going to just hook up my viewer to the merge node, and I'm going to hook up my new image where the original matte painting was. Okay. The only thing I need to do now is I need to apply the new focal length into my projection camera. So we've got this is still at 42 from the previous exercise, and this time we want to change it. I've still got my 31.744 in the clipboard, so I can pop that in now. If we take a look at this in 3D view now, we can see that projection camera's focal length is now much shallower and wider, so we know that that's projecting out a lot more, which is consistent with the extra overscanning that would be necessary to deal with the extra resolution that we've created with this 2500 by 1406. So let's just select the merge node and just get in here nice and tight, and then we'll just start toggling the disable button on this, and we can see there that this is matching up perfectly. We can see there's no change. Again, if we go in close, we may see slight changes there with the pixels, but when you go this route you tend to get fewer errors because the resolution is actually being calculated as a whole integer in Photoshop rather than created as a partial integer from the perspective of the focal length. Anyway, that's pretty much it. It does feel really quick, but that's because we did most of the heavy lifting on the project in the previous demo, and we've also been able to reuse most of the previous script. Anyway, I hope you found it useful and that you'll be able to apply this in your own projects.